And once we make those observations, what do we do with those observations? Well, we might ask a question. Why is the sky blue sometimes, and sometimes it's pinkish orange? Right? That's not chemistry, but you get the idea. We see this beautiness around us and say, okay, but why? Why is it this way sometimes and sometimes it's that way? Or whatever. So we ask a question. Or questions. Or we notice a problem or define a problem. So we use this scientific method. We can use it in our day-to-day living. You guys have problems or questions in your day-to-day lives? I hope so. Otherwise, you're probably not human, right? So we all have them. Well, I can ask myself, I can see that I'm in a wheelchair. How do I get out of this wheelchair? How do I learn to walk again? Anybody think that's possible? For me, I've been in it for 22 years. I think it's just stuck, right? Well, that's only stuck if it's in my head that it's stuck. I've always pushed try to find out ways to heal myself. And I still feel like there's a way to heal myself. But this is a problem I have, and I can use the scientific process to maybe get there. So my question is, what do I got to do to get up? And I might have smaller goals to get my body to where maybe my legs are more limber, so eventually I could use them to walk, right? Because you guys know that if you don't use something, you have atrophy and your muscles shrink, and well, it's kind of what's going down to my muscles right now. And so I got to do a lot of things. So here's my question. What do I do after I have a question or I have a problem? Now what? Oh, what? Make a hypothesis. Yeah, that sounds sciencey, right? Yeah, but what does that mean? We try to answer our question. We try to solve our problem. Come up with the best answer based on our experiences, our background knowledge, what we've learned in the past, okay? So make a hypothesis, or make hypotheses, rather, more than one. So a hypothesis is an educated guess. It's not like I choose B. Okay, we're not guessing. It's not just a guessing game, but we use our understanding, our background knowledge, our experiences, our research to come up with an answer. Okay. And our next step, I'm going to leave a little bit of space right here on purpose. So maybe you should leave a little bit of space on here. So maybe I'll just do this here. I'm going to write something right underneath that. And step 3 is, once we think we know what the answer is, now what? We've got to test it, see if we're right? Test our hypotheses. Make an experiment, right? So what kind of hypothesis, how do we know if our hypothesis is scientific? If we can follow this process, right? So
I think so you can test it over and over again.
Yeah, we know it's scientific if we can test it, right? If we can't test it, so for example, we might have a question that is, what's the most powerful force in the universe? My hypothesis, I think it's love, right? I think love is the most powerful force in the universe. I'm just teasing, but is that scientific? How are we going to test it, right? I don't know. Does it cause us to accelerate? Probably not. Whatever. But so it must be testable. Okay? So during our testing of our hypotheses, we should collect our data. So when I got my master's in chemistry, then my project was on global temperatures, Earth temperatures, atmospheric temperatures, and well, why? You heard of global warming, right? Are we in over our head? Is the Earth gonna just get too hot and melt the poles, and we're just gonna be in trouble? What do you think? I don't know. Well, there was a lot of data. We took temperatures from the Earth and the atmosphere every half hour for 10 years. Now, I didn't collect all this data, but we have all this data, right? If that's all we have, is that useful? No, we got to make sense of it. So we got to analyze our data. Or make sense of it. What does it say? What is it telling us? Okay. But going back to my project, I don't know, it seems like sometimes we're they try to put fear into us. And, well, is it a thing? My findings is, yeah, it's a thing. The globe is warming. But if we have 10 years and it's saying it's warming, is that enough to say it's going to continue to warm? No. So here's what it did. It went up and down for the summer and winter, right? And then it kind of does this. Maybe not that steep, but I'm just, okay. Okay, there's our 10 years. But what about the 1,000 years before? What did it do? Well, we heard about an ice age, right? Well, that was like, what we hear is millions of years ago. Who knows, right? But there's an ice age. Any possibility that it could do this and then go back up? Possibility, right? Does that mean we shouldn't worry about our environment? So, yeah, I could just drive all I want and burn all the fossil fuels I want, and we're going to be fine, right? Because before it rained, you saw how it was, right? It's like, yuck. Think that's bad for our health? It may be. So, yeah, maybe we should try to make things better. But should we throw out all the gas-powered cars because too much pollution? We wouldn't be able to function if we did that. So are electric cars great? Some of it, they say maybe not. They are more efficient, but you still have to charge them with fossil fuels. We can't get away from fossil fuels today, ladies and gentlemen. Let's gradually get there, right? And there's other methods of energy, but anyway, that's not this topic, okay? But, so analyze the data. How do we analyze data? We make graphs and charts, models, diagrams of what our data says, so that we can kind of see it and understand what's going on. And we can convey all this information to somebody else. Because if we don't, then human race isn't going to make progress, right? We've got to put it out there, and that's kind of our next step. Last step is pose a theory. Based on all of our evidences, and we better have tons of evidence. Otherwise, this much isn't going to tell us what's going to happen, right? So we got to put out, okay, these are my findings. put it out there, so we write our theory, right, and we publish that theory. So publish and get peer reviews. If we don't let other people see what we're doing, we're not going to make progress very fast. You've got to put it out there. Okay? And we go back and forth, back and forth, back and forth. So maybe we ask a question, we have a hypothesis and we test and we say, oh, okay, that didn't quite work. Okay, go back to round one. Maybe we have a different question. We see something in our experiments. Oh, but what about this, right? We have a different question. Or we might have another hypothesis that we test. All these things, we're going back and forth, back and forth, back and forth. So we got to repeat. Okay? Until we get enough conclusive data that tells us, okay, data, this is what it is. Then we have a theory. What makes it a law? Anybody know the difference of theory and a law? Most people say a law has been proven true and the theory hasn't. But that's not the case. I'm just trying to get that out of our brains. They're almost the same. So a theory attempts to explain why something does what it does. And the law attempts to explain how something does what it does. Okay? So they're almost the same. Oh, sorry, it's so hot in here. But a law, so let's talk about a theory real quick. In fact, let's maybe be specific here. The Big Bang Theory. What do you think? Did our universe start with the Big Bang? That's what we're taught, right? Well, do we have evidences of it? In fact, we do. We have evidences that, in fact, let me just tell you something. When I was younger, based on my belief system and how I was brought up, I thought, yeah, whatever. Yeah, whatever. How do they even know that? Whatever. And you just kind of ignore it and you kind of, that can't know. And is it okay to have your own opinion? It is. But as a scientist or in science, we try to find out what is true. And if we just push something, no, it can't be. That goes against my belief system. Then we won't ever find the truth. So later, as I learned, as I progressed, as I got older and grew up or whatever, I could say, okay, yeah, the universe is expanding. We can see that. And the last couple of years, not only is it expanding, it is accelerating. That's pretty cool, actually. What causes acceleration? If you take in physics, we know it's a force. A force causes acceleration. We got force of gravity pulling everything together. But we got a force pushing this stuff out. If it's accelerating, holy cow, we don't know what it is. We don't know what causes it. There are so many holes in our knowledge. But we know the universe is expanding, and that's what happens in a big bang, right? Or in a little bang even. It expands. And, well, physics tells us it expands and then it just keeps going because of inertia, right? I don't know if you understand that. You don't have to. But, okay, there's evidences that maybe an explosion happened. And we see that a star explodes, right? A star will explode. We've actually seen that happen. A star will explode, and then what happens? Gravity pulls it back in. Boom. Boom. and this happens over a lot of years, but okay. But we've seen that, so we have evidences that, okay, this is what we can see. So theory, is it law? Why isn't this a law?
Because you can't prove it as an absolute.
We can't prove any law. What are we trying to do? We're trying to disprove. We're trying to prove that it's wrong. But, so I'm glad you brought that up, because that's a lot of us think a law is something that is proven. It really hasn't been proven. We just haven't been able to prove it wrong yet. Okay? We haven't been able to prove the Big Bang Theory wrong yet either. So what makes it a theory versus a law? Well, can we test that it started billions and billions of years ago? Can we test that that's what actually happened? So the universe as we know it, we can see right here. Maybe there's more, but we just can't see it, right? So maybe there's an explosion, but maybe there's one over here too. I don't know. So there's a lot of holes in it, and that's why it's not a law. Are we good? Do you kind of get the difference?
So there's like, what you're saying is like with a theory, there's a lot of gaps in its explanation, but with a law, you have, I'm not trying to sound like super intelligent or anything, but it looks like you have like a more linear explanation to establish, hey, at least we have enough evidence to suggest we can abide by this, because we have enough evidence to say we have a more linear explanation. Whereas with the holes, it's like, yeah, it kind of, sort of, but it's up to debate. But with the law, it's like, hey, we have something a little bit more permeable.
Yeah. And so kind of like the law of gravity. We have an equation that looks like this, and I'm not going to explain this equation. But everything as we know it follows that equation. Everything in space, everything on the earth, everything as we know it follows that equation. And we use that equation to figure out a lot of things in space. Kind of wonder how we know some stuff in space, right? How do we know the mass of a star? How do we know all this stuff? With equations. And if we have an equation, that kind of tells us it's a law if everything follows it, right? So there's no holes there. Everything follows that. Yeah. Are we okay? Any comment? I don't pretend to know everything about everything. I don't. Any comment? Maybe you have other understanding, maybe that I have holes, right? Okay? So just something to think about. Don't push it out. Don't say, okay, whatever. How do they even know that? For example, the atomic theory. How do we even know that an atom is made of, right? How do we know that? Can't see it. Because we know other physical properties. We know what happens when like charges come together, they repel. We know these things. And so we can kind of see that. And we have electron microscopes that kind of show us behaviors of these things. And it kind of, okay, that supports this idea or this theory, right? Okay, any questions about the scientific process, laws and theories? Yeah.
I just looked up just on Google, just theory versus law. Is this like too simple of an answer? It said theory is why something happens, law is how something happens. Like, is that not quite like?
Is that? Did I mention that?
Yeah. Okay. Great.
Rocked
All
it.
right.
Okay, yeah, that's it. So they're really close, aren't they? Really close. And a lot of people think, and especially in high school, because I get a lot of kids that come through there, and they think a theory is just somebody's idea, and it's not. Okay? It really is backed up by a lot of evidence. Good. Anything else? All right. So get started right away. Don't wait till it's actually due. But let's get started. Start reading our book and start doing the assignments, and come with questions or ask questions through Canvas. I'll respond within 24, 48 hours. Okay. But let's get something out of this class, and let's try to enjoy it. Think about all of the things that you do enjoy. Why is it that you enjoy learning how to play guitar, for example? Or maybe why is it that you don't enjoy learning how to play the guitar? Maybe we have some of those same things, some of you with both of those ideas in this room, right? So we like to play the guitar because there's something that's telling us, ooh, I just want to get good. It's going to sound so good. I see my progress, and I'm going to get good at it, and oh, I just love it. And some people struggle with it, whatever, and you break their guitar, or whatever, right? But if we have a little sliver of a desire to learn this stuff, it'll grow and grow and grow and grow until this stuff is pretty cool, actually. How do I know? Because it happened with me. Okay. I don't have anything more for you tonight, unless you guys have any questions. And we won't always have a short night, but I think a short night right at first is good, especially when it's hot in here. Sorry about that. There's no thermostat. I'm going to have to go ask them, how do we get this room cooler? So have a great night. Drive safe. And thank you for coming.